Good morning, everyone. Come on, it's a Tuesday morning. You can give me a better morning. Good morning, everyone. Okay, that sounds more like it. So, my name is Freddie Mashate, and I'm the venue manager for this particular venue. Welcome all to Scifest Africa, 20th anniversary. Are you excited? Welcome to the laser show. So before we begin, I'm just going to call. His name is Dr. Stephen Ashworth to just talk to us about the laser show a bit for I don't know how many minutes. So please help me welcome Dr. Stephen Ashworth.
Well, thank you very much for that introduction, and welcome once again. Good morning, everybody. Okay, now I know this is the first day of Scifest. You need some training. That is a 2 on the good morning scale. So we need to get it up to at least 8. So good morning, everybody. Yeah, 8.2. Okay, that's a good start. And we have a packed program for you at Scifest, and I hope you're going to be able to get to do and see lots of things. But the first thing, I've been asked to tell you a bit about lasers because in my career in doing research as a research scientist back in the UK, I have had to work with various lasers, build some, and use lots of different ones. So why is laser light special? Well, laser light is special because of the way we make it. Laser actually comes from the words light amplification by stimulated emission of radiation. I hope you can remember that. There will be a test later. Okay, light amplification by stimulated emission of radiation. What we're doing is we're intensifying the light. We're turning it up, just like you turn up the knob on your MP3 player or your phone or something to make it louder. We're making the light brighter. And this process of stimulated emission means that laser light has some interesting properties. If you look at the lights up above you, these are just normal lights. You can see the light spreading out in all directions. I have a laser here, and you can see that light doesn't spread out. It just hits the wall, just a little green spot over there, a little green spot over here. And you only see that light where it splashes. It's traveling in a straight line, and laser light tends to travel all together in a bunch in that beam that you see. And this is one of the reasons we fill the auditorium with this sort of haze. It's so that where the laser light hits these little particles in the air, it sort of splashes and gets into your eyes. Otherwise, you wouldn't see anything. If you were in a completely clean room, you'd only see the laser where it hit the wall. You're going to see the laser light because it's splashing off all these little particles. And when we draw pictures, there's a curtain back here where the lasers are hitting, and again, the light is splashing, and so it reaches your eyes. Another thing you'll notice, I have 2 lasers here. One's green and one's red. One's green and one's red. Lasers give out a very narrow bandwidth of light in general. Most lasers give only a very, very small bandwidth. So they're called monochromatic. They're one color. What you're going to see today is lots of colors. And what will happen is that some of those lasers will combine and you'll see white. And so just like on a mobile phone screen where there's a red and a green and a blue pixels, these little dots of color, and when they're all lit up they form white, the same thing will happen with the lasers. We have to combine different color lasers to make the whole range of colors. Now laser light has a really, really special property because of the way it's made, and that is the property of coherence. If you think of light as a wave, it goes like this. And when it's traveling this way, it goes like this. So it's got a peak at the top and a trough at the bottom. And in laser light, all the peaks line up and all the troughs line up. And this means you can do really special things with lasers. Have you heard of the recent discovery of gravitational waves? Yes, well that was done with an instrument using lasers. It was the lasers, this property of the coherence of lasers, the fact that all the peaks line up, the troughs line up, enabled those scientists to measure a distance that's less than the width of an atom. using lasers. So that the laser light gives us this special properties that we can use in scientific instruments, in measurements, all sorts of things. It also means that we can use it in everyday life. Who here has, did anyone been shopping recently? Gone to the shops where maybe a big shop where they've just scanned your goods? Yeah, that's a laser doing the scanning. Has anyone made a telephone call recently? I know it's a bit passé these days, isn't it? To actually make a telephone call and speak to someone. You generally send them a text or a sticker or a smiley or an emoji what's it. But if you've made a phone call, the chances are that some of that phone call will have been squirted down an optical fibre by a laser. Has anyone got or have used a laser printer? I know that up in the offices, so if you've got some printouts from the offices here, you may well have that done by a laser printer, or even an inkjet printer. Now the laser printer has a laser built into it. The inkjet printer has the holes that the ink squirts out of, made by a laser. Because lasers, because of these special properties, we can manipulate the light very, very easily. Some of you will be wearing clothes that were cut out using a laser. Some of you will have come here in a vehicle where the body panels will have been cut out using a laser, or maybe welded together using a laser. So they're in use all around us. Now, if you want to get involved with lasers, there's several ways of doing it. You could become a research scientist, a physicist, and invent a new laser. You could develop a laser, make it more powerful, make it smaller, make it cheaper, faster, lighter, whatever, bigger. So that's the physicist then. You could build them into instruments. You could use the special properties and manufacture things, develop new scientific instruments. You could use them in your field of work just as a tool. So if you were a surveyor of some kind looking to find out whether something was level, you wanted to build a new road, you might use a laser to help you with that. So there are all sorts of ways you can use lasers. And if you want to talk to some laser scientists, I believe up on the CSIR stand, there is some real live, living, breathing laser scientists that you'll be able to talk to about lasers. But of course, another place that you can use lasers is in the creative industries, the creative arts. And we are going to see an example of that today. I've had a sneak preview, and you're in for a fantastic show. So here is an example of lasers used in the creative arts. I ask you to sit back, relax, and enjoy the show. Thank you very much.
Don't tell the gods I left a mess, I can't undo what has been done. Let's run for cover. What if I'm the only hero left? You better fire off your gun once and forever. He said go dry your eyes and live your life like there is no tomorrow, son. And tell the others to go singing like a hummingbird, the greatest anthem ever heard. We are the heroes of our time, but we're dancing with the demons in our minds. We are the heroes of our time, heroes. But we're dancing with the demons in our minds. Heroes. We are the heroes of our time. Heroes. But we're dancing with the demons in our minds. Heroes. The crickets sing a song for you. Don't say a word, don't make a sound. It's life's creation. I make worms turn into butterflies, wake up and turn this world around in appreciation. He said I'm never left aside when you were lost, I'll follow right behind. Was your foundation. Now go singing like a hummingbird, the greatest anthem ever heard. Now sing together. We are the heroes of our time. Heroes. But we're dancing with the demons in our minds. Heroes. We are the heroes. Now go singing like a hummingbird, the greatest anthem ever heard. Now sing together. We are the heroes of our time. Heroes. But we're dancing with the demons in our minds. Heroes. We are the heroes of our time. Heroes. But we're dancing with the demons in our minds. Heroes. We are the heroes.
I was left to my own devices. Many days fell away with nothing to show, and the walls kept tumbling down in the city that we love. Great clouds roll over the hills, bringing darkness from above. But if you close your eyes, does it almost feel like nothing changed at all? And if you close your eyes, does it almost feel like you've been here before? How am I gonna be an optimist about this? How am I gonna be an optimist about this? But if you close your eyes, we were caught up and lost in all of our vices. In your pose as the dust settled around us, and the walls kept tumbling down in the city that we love. Great clouds roll over the hills, bringing darkness for both. But if you close your eyes, does it almost feel like nothing changed at all? And if you close your eyes, does it almost feel like you've been here before? How am I gonna be an optimist about this? How am I gonna be an optimist about this? But if you close your eyes, but if you close your eyes,